Dear students, look into these pictures. The first picture you can see the water striders. They can walk easily through the surface of water. They are not sinking. And the second picture also you can see a blade. Even though it is denser than water, we can float the blade on the surface of water. In the similar way, a needle also, we can keep the needle as a floating position on the surface of water. On the bottom, you can see a drop of water that is coming out of the tap. It has the shape, the spherical shape. It has the shape of a sphere, and also the bubble, the soap bubbles or air bubbles. So they are formed at the shape is also the spherical shape. So what is the reason behind this kind of properties? So this kind of properties uh, can be attributed that is we call them surface tension. So what is the surface tension? Here, in the above examples, we can see that the surface of the liquid that is behaves like a membrane under tension. That is, it behaves like a stretched membrane. Okay. So what is how the surface of water or surface of the liquid behaves like a stretched membrane? That is because here the molecules of the liquid exert an attractive force on each other. We know, suppose in the figure we can see there is a container and there is some fluids, the fluid is there. So when we consider a molecule uh, inside inside a fluid, it is attracted by and or it can interact with all other molecules. So, so it is attracted by all other molecules by the some molecular forces like van der Waals forces. But look into the a molecule on the surface of water. So, at the surface of water, the fluid molecules can interact with the air molecules above, and the fluid particles can interact with this surface molecule that is only the below the surface. So there is a net force is acting on the surface molecules because due to the attractive force of the molecule, the fluid molecules just below the surface of water. So what happened? So there is a net downward forces acting on the surface. So due to this net downward force, the surface or the surface liquid tends to minimize its surface area. So that is then it is behaves like a stretched membrane. So that is the reason behind how this the liquid surface acting like a stretched membrane. Okay. So in the above examples, we can see that when the blade or the needle, even though it is the both are denser than the liquid, uh, it can float on the surface because here the surface of the liquid or the water they are behaves like a stretched membrane, and they can balance the weight of the blade or the weight of the needle. And also when the water is coming out of the tap, uh, here the water accumulates as though it were collected in an invisible membrane until of a definite size. Then when it is discharged, it has a spherical drop. These effects are due to the forces existing on the surface of the separation of liquid from the air and the other media in contact with it. When the liquids acquire a free surface, when poured into a container. These surfaces possess some additional energy. These surfaces possess some additional energy, and this phenomena is known as the surface tension. This phenomena is known as the surface tension, and it is concerned with only liquid because the gases do not have any free surface. The gases do not have any free surfaces. So the surface tension can be defined as, so it is the property of a liquid surface to reduce its surface area to minimum as possible due to the force exerted on the molecules of the surface by the molecules of the bulk. So this we can define this surface tension like this. So it is a property of a liquid surface to reduce the surface area to a minimum as possible due to the force exerted on the molecules of the surface by the molecules of the bulk. Okay, we know a sphere has a smaller surface area for its given volume. So, for if we are taking a given volume of material, when we put the material into a shape with a minimum surface area, then you can see that the sphere has a smaller surface area than any other shape. So that is why the freely falling raindrops are spherical in shape. So when the raindrops are coming down, and when it is there is a surface which is contact with the air, so there is a surface tension is acting. So due to the presence of surface tension, the surface of the raindrops like to minimize its surface area. Okay, so to get a minimum surface area, the preferable shape is the sphere. That is why the raindrops are become not a raindrops. So all other water drops are become spherical in shape. Now we are going to calculate the surface tension. Okay. Here, consider a line AB is drawn on the surface of the liquid. A surface of the liquid. Here the line divides the surface into two parts. Divide the line into two parts. And since the liquid surface behaves like a stretched membrane, the two parts of the stretched the surface pull each other. They pull each other. Here we have the one part. Here we have another part. So here since they behaves like a stretched membrane, they are pulling each other with a force, and that force is proportional to the length. The force is proportional to the length of the line AB. Okay. Suppose F is the magnitude of the force acting perpendicular to the line AB, and the length of the AB is L. Then the F is proportional to L, or F equal to a constant into L. Here the S is the constant, and this constant of proportionality is called a surface tension. Okay, from this S equal to F by L. Okay, that is so the force per unit length. So surface tension can also be defined like this. It is the force per unit length acting tangential to the surface of the liquid to reduce the surface area of the liquid. So it can be defined as the force per unit length acting tangential. That means the force is acting parallel to the surface. The surface tension is acting parallel to the surface. That is, so it is defined as the force per unit length acting tangential to the surface of the liquid to reduce the surface area of the liquid. Okay. So from this we can have the SI unit of surface tension. So since S equal to F by L, so SI unit of surface tension is Newton per meter. Newton per meter. Okay. Now, since here the surface of the liquid is acting like a stretched membrane, and the molecules on the surface have a net downward force, and correspondingly they have a more potential energy than the molecule inside the liquid. Okay, so there is some additional energy for the molecules on the surface. So this extra energy possessed by the surface layer of the liquid is called surface energy. It is called surface energy. So the surface energy can be defined as the work done to increase the surface area of the liquid. It is the work done to increase the surface area of the liquid, because each surface acts like a stretched membrane, and it is reduced to and is try to reduce the surface area. So to increase the surface area, we have to do some additional work. Okay, so that corresponds to the energy of the molecules on the liquid surface. So surface energy can be defined as the work done to increase the surface area of the liquid. So the surface energy is related to the surface tension by the equation, that is surface energy is equal to surface tension into area of the liquid surface. Surface energy is equal to surface tension into area of the liquid surface. That is U is equal to S into A, or S equal to U by A. S equal to U by A. Okay. Then we can also define the surface tension as the surface energy per unit area of the liquid surface. The surface energy per unit area of the liquid surface. So this is another definition for the surface tension. Now let us see. We know the molecules. The molecules of any fluid, they can attract. They have some molecular attractive force. There are two types of attractions. If the molecules of the same kind are attract, then it is called adhesion. It is called adhesion. And if the molecules are of the different kinds, if they attract, then that attractive force is called cohesion. Cohesion. Okay. So the attractive force acting between the molecules of the same kind are called the cohesive forces, and similarly the attractive forces acting between the molecules of the different kinds are called adhesive forces. Okay. If the two water drops, they are the same kind, they attract. So the force between the water molecules is called a cohesive force. Okay. At the same time, when the water drops is placed on a glass plate, so there is also some attractive force between the molecules of the water and the molecules of the glass plate. So these are the molecules are of the different kind, and this corresponding attractive force is called the adhesive force. This adhesive force may occur between solid, liquid, or gaseous material. Okay. For when a liquid in contact with a solid surface, the wetting of the surface depends on occurs. The wetting of the surface occurs. That is depending on the ratio of the strength of the cohesive and adhesive forces. Cohesive and adhesive forces. Okay. So when the force of attraction between the liquid and the surface, uh, surface molecule. So when the adhesive force dominate, okay, if that adhesive force dominate, then the surface tension of the liquid becomes low, and the liquid spreads over the entire solid surface. So we call the perfect wetting. Okay. So if the cohesive force dominate, that is the force of attraction between the water molecules. If the cohesive force dominate, what will happen? Here, the adhesive force, the force between the water and the surface molecule, so that is less dominant, and due to the domination of the cohesive force, uh, here the liquid has a tendency to contract into drops, and that means it doesn't wet the surface. So it is a bad wetting or no wetting. Okay. So in each case you can see here we have a so that is means the wetting of liquid on a surface, that depends on the type of the force dominates. uh, out of which cohesive and adhesive forces. If the cohesive force dominates, then there is no wetting. If the adhesive force dominates, we have a perfect or complete wetting. Now we have an angle of contact. What is the angle of contact here? Here, when a surface of liquid near the plane of contact with another medium, then we can see that it is generally curved. It is generally curved. So when you do the experiment in your chemistry lab, suppose you are taking a liquid, whether it is an acid or alkaline, the diluted one that is taken in a burette, and you are asked to find the level of the liquid. So you can see that at the liquid surface that is near to the glass tube is in curved shape. Okay, so here the angle between you can see in the figure here the angle between uh, the surface, the liquid surface, the angle between the liquid surface and the solid surface at the point of contact is called the angle of contact. So in this case, you can see this is a liquid surface, and this is the liquid surface, and this is the solid surface. So this is the angle of contact. So this angle is obtuse. This angle is so this angle of contact will determine uh, uh, whether a liquid will spread on the surface of the solid or it will form a droplet on it. So this angle of contact is different for the different pairs of liquid and solids. Here we can see that if theta is an obtuse angle, so then you can see that if theta is an obtuse angle, the molecules of the liquids are attracted strongly to themselves and weakly those of solids. So the liquid does not wet the solid surface. So what is obtuse angle? We know obtuse angle is any angle that is greater than 90 degree. 90 degree. Okay. Here, this angle. This angle is theta. That is the liquid, the solid surface, and the angle between the angle tangent to the liquid surface at the point of contact, and then this tangent. So this is the angle of contact. You can see this angle is obtuse, and that means here the cohesive force are dominating. The molecules of the liquid are attracted strongly to themselves, and they are weakly to those of solid. So that means they become they doesn't wet the solid surface, and they become more spherical in shape. But in some pair of liquid and solid surface, we can see that here the angle of contact is an acute angle. So that is what is acute angle. The acute angle is an angle is less than 90 degree, less than 90 degree. So uh, in this case, angle is less than 90 degree. That is, here is the angle of this is the solid surface, and here this is the tangent, and this is the angle. So you can see this angle is less than 90 degree. That is this acute angle. So that means the liquid molecules are strongly attracted to the molecules of the solid, and the liquid gets easily wet to the solid surface. Okay, this is what happens with water or kerosene on glass or plastic or any other surface. But in the case of the when angle of contact become obtuse, that is you can see that it happens in the case of water on a waxy or oily surface, and also you can see the water on the lotus leaf, and also you can see the mercury on any surface it doesn't wet the surface, we know. So that is the angle between the liquid, the mercury and the any solid surface is always higher. That means it is an opticine. Okay, we know the water forms droplets on lotus since they have a large angle of contact. Okay, that is why the lotus leaf is hydrophobic in nature. You can see the water doesn't wet the lotus leaf because that is why in the lotus leaf become hydrophobic. That means water drop has less contact area with the lotus leaf surface. Okay. But for the herbicides, the herbicides for the herbicides, the angle of contact with the leaves should be small. It should be small so that it would have a larger contact area to the leaf, so they can easily wet the leaf. So that is why they should be hydrophilic in nature, so that the herbicides can effectively act on the herb's leaf and destroy it. And also you can see uh, some waterproofing agents and also the paints used in buildings and other constructions. Uh, they are argued that their painting will last long for more than 10 years. So how can they do that? So actually they are creating a large angle of contact between the water and the fibers in it. Okay, so they have a in paint there is a there is a very small fibers. So during the process of that fiber, what happened there is a the angle of contact between the water and the fibers, that is we have a large angle of contact. That means the water will become more spherical in nature and it doesn't wet the surface. So so the surface will become hydrophobic in nature, and that helps the walls of the building from wetting uh, due to rain or some other water sources. Suppose we have a tube. When one end of a tube is very small radius and it is when dipped into a liquid, there is some phenomena that you can see that the liquid rises or falls in the tube. Suppose if you can do in your home, please take a refill, an empty refill of your pen, and you can dip into in a glass of water, and you can see the water just rises in a tube that is above the water surface. Okay, so this phenomena, that is when a small radius tube, that is we call the capillary tube, is depending in a liquid, what happen, the liquid rises or falls in the tube. This phenomena is called a capillarity. This phenomena is called a capillarity. Okay, and the rise or fall of liquid in the capillary tube, that depends on the angle of contact, between the liquid and the surface, the liquid and the tube. Okay, if the angle of contact is less than 90 degrees, that is acute angle. Here you can see here the angle of contact in the case of uh, water. Suppose you are placing a capillary tube in a water. The angle of contact is less than 90 degree. That is a acute angle. The liquid will rise in the tube. Okay. Here the angle is acute. Here this is the solid surface, and also here this is the tangent to the liquid surface. So this angle is theta. That is obviously this angle is an acute angle. So in that case, the water will the liquid will rises in the tube, and it is called a capillary rise. So here we have a capillary rise. On the right side, if the angle, suppose we are taking if we are placing the capillary tube in a mercury, then in that case the angle of contact is obtuse. You can see the angle of contact is obtuse. This is the solid surface, and this is the tangent to the mercury surface. So this theta, that is greater than 90 degree, and is an obtuse angle. So the liquid falls in the tube, and this is called a capillary depression. Capillary depression. So capillary rise and capillary depression. So for the capillary rise, the angle of contact is acute angle, and for the capillary depression, the angle of contact is obtuse. Now we have a formula for the how much the liquid rises or how the liquid falls in a capillary tube. That's against the gravity. Uh, we know that is due to the surface tension, and the height, the elevation height of the liquid in a capillary tube is given by the Ascent formula. We call it Ascent formula. We are not going the derivation of that formula. We are just study directly the formula, that is H is equal to 2s cos theta divided by r rho g. The Ascent formula H is equal to 2s cos theta divided by r rho g. Let us see what are the terms. Here S is the surface tension of the liquid. This is the surface tension of the liquid, and theta is the angle of contact between the surface of the liquid and the surface of the capillary tube at the point of contact. You can see this is the angle of contact. That is the angle between the surface of the liquid, and this is the surface of the liquid, that is along the tangent, and the surface of the capillary tube. This is the surface of the capillary tube at the point of contact. So this angle theta is, that is the theta is this angle of contact, and r is the small r is the radius of the capillary tube at the radius of the capillary tube, and rho, what is rho? Rho is the density of the liquid rising through the capillary tube, and g is the acceleration due to gravity. So from this expression, it is clear that for a given substance, the elevation depends only on the radius of the capillary. Okay. So for a given substance, the elevation depends only on the radius of the capillary. Okay. Now let us see some of the applications of surface tension. Here, the action of, usually we are using water for the washing of clothes, but this water does not remove the grease or oil stains, because the water does not wet this kind of dirt, because there is only very little contact area between them. If the water could wet the grease, then the flow of water could carry some grease away. Something this sort is achieved by doing the detergent. Okay, this can be this cleaning of the dirt like grease, oil, etc. from the clothes, that can be done with the help of detergent. So the detergent, they have the molecules of detergent, they have a hairpin shaped structure, and due to this, the one end can be attracted to the water, and the other end connected to the molecules of grease or oil or wax. Thus, they are tending to form a water oil surface, a water oil interface. Okay, so they can easily remove the dirty the dirtiness, the dirty material like grease, oil, or wax. And in addition to this, this above fact, there is also one more thing: the addition of detergent whose molecules attract to one end and say oil on the other, and reduces drastically the surface tension. That is the water oil. The surface tension of the water oil interface, that become energetically favorable to form such interface. So what happen? The globes of dirt surrounded by the detergent, and then by the water. So due to this hairpin structure, They can easily connect both the liquid and both the water and the dirt. And at the same time, uh, this addition of detergent, it will cover it will surrounding the oil or the dirt molecules, and also then again surrounded by the water molecules. Okay, so we have a globes of dirt are there, so they can be easily remove the dirts like this. So this kind of process using the surface active detergent or surfactants is important not only for cleaning but also in recovering oil, mineral, or etc. So this kind of surfactants, they have another application in the case of the ore extractions. Okay, the mineral ore extractions or for recovering oil. So due to this special structure of the detergent molecule. And another example, that is the farmers are plowing the land in the summer season. The farmers plow the land in the summer season. We know in the summer season means there is a scarcity of water, and so when the land is plowed, the separation between the soil particle increases. Okay, so the capillarity, the diameter of when the summer season, when the air is already evaporated and the soil become more dense. That means the separation between the molecules have become very less. So there is a we can see there is a formation of the capillary tubes. So due to this very small capillary tubes, the small holes, the water can rise to the top surface, when it's the ground, and they may escape due to the evaporation. Okay, so to prevent this, usually the farmers are plowed the land. Okay, so when the land is plowed, the separation between the soil and the particles increases. So the diameter of the capillary tubes form in the soil also increases. So the capillary rise decreases. This helps to retain the moisture in the soil. So this is the reason why uh, the farmers doing for plowing the land during the summer season. And the another example for here we have the effect of temperature and impurities on the surface tension. Okay. So what will happen if we increase the temperature? So usually in the case of the liquid, the surface tension of a liquid decreases with the increase in the temperature of the liquid. So when we use the hot water for cleaning the clothes, they can easily wet the clothes and thereby cleaning the clothes. Okay, that is because so it decreases when we add the hot water, the surface tension will become decreased, and the wetting will be more easier, and they can easily remove the dirt. Okay. And why? This is because the Coxy forces decrease with increase in molecular thermal activity, and the angle of contact also decreases with increase in temperature of the fluid. So what happens is the dissolved impurities. Okay, in the case of the dissolved impurities, like the common salt, here the surface tension of the liquid increases. The surface tension of the liquid increases with the addition of or with the concentration of dissolved impurities like common salt. But in the case of the dissolved impurities, the surface tension increases linearly with the concentration of dissolved materials that we have already seen. But in the case of the insoluble impurities, if we add the insoluble impurities like oil, grease, etc., then the presence of insoluble impurities will decrease the surface tension of the liquid. Okay, so The addition of insoluble impurities decrease the surface tension of the liquid. The addition of the common salt, that is the surface tension in that case increases with the concentration of dissolved impurities.